So good morning guys. Today we will be solving this problem. So I got this problem from this book. So page page 65. So this is our problem. The problem state that the fink truss shown in figure P-322 is supported by a roller end at A and a hinge at B. So this is the roller and this is the hinge support. So given the loads are normal, so when we say normal, it means it is perpendicular to the inclined. So normal to the inclined member. Determine the reactions at A. So the reaction at A and B. Hint: replace the loads by their resultant. So RA is 4620 and also RB is 4620. So RB have an angle of 30 degrees with the horizontal. So we can now start. So first, as the book gives us a hint, so we would like to find the resultant of these forces. So as you can see, this the order of the forces is symmetrical. So obviously the force will fall here for in this line, but we don't know the distance of this line to either A or B. So that is our first problem to solve, because the resultant is just the summation of this force, and because these forces are going in one direction and have the same what you call this yes, the same direction, the same angle, so we can just add up all the forces, so we can have the resultant. So 2 6, so we have 8,000 pounds lb. This is our resultant that will fall in this line, 8,000. So now we would like to find the distance of this point to A or B. So to do that, this is a 60, we have a 60 length truss. So if we put a line here in the middle, so here, yes, so this will be 30 degrees, 30 feet from both sides, so 30 feet to A and B. Now what I would like to do is to solve, because I know that this is 30 feet, so I just want to know the length of this, so I can subtract it, so we will get the length. So now we have 30, so we would like to find this length. So to do that, 30 and the angle, so the angle here is the book, I think the book already gives the angle there, yes, so the book has 30 degrees both sides, so we would like to put 30 degrees here, 30 degrees also here. So now by using adjacent and opposite, so tangent of the theta, tangent of 30 is just equal to opposite, so h, this is h over adjacent of 30. So I am considering this half triangle, so over 30. So we can derive it and we will get our h. So our h is just equal to process 17.32 feet. So this is our h. So now I have this and I have an angle, so because this is a 90 degrees perpendicular, so obviously this will be just 30 degrees. So by using this height as our adjacent and this angle 30 degrees, we can solve this opposite and again by using the tangent. So tangent of this small triangle here, so tangent of 30 is just equal to, so I will put this on x, so this is x. So x over 17, so I am using the h, 17.32. so our x is just equal to so 9.99, or we can just say it's 10 feet. So we already have the x here, so because this is 30 and that x is 10, so obviously this the distance from A to this point, so I will put this point as point C. So A to C is 20 feet and C to B is 40 feet. So now we have the distance and we can now sum up moment to either both sides. So we can solve for this RA because we are asked to solve for RA and RB. So remember that if the support is a roller, so it have only one reaction, which is going up. So we can put RAY or just RA because that is the reaction for that roller support. But on the hinge, so the difference is the roller has roller there, so it is a roller. So in the hinge we have two reactions or the components of the reaction. So RBY and RBX, it is always present in the hinge support. So what we would like to do now is sum up moment. We can do on both sides. So I would like to sum up moment at B because there is two unknowns there, and we know that if we sum up moment where in the point where there is a force, so that force will become 0. So our what we can solve is the RA. So now summing up moment at B equals to RA times, so RA is force and times the moment arm of 60, so positive. And you already know that our resultant that will fall here is 8,000. So this have here 8,000 pounds. So because this is a 90 degrees, so our resultant also have 60 degrees to the horizontal. So 8,000, so negative minus 8,000 sine of 60. So the what we will be using for the resultant is the y component of the resultant, because if you notice, the x component of it will go directly to our moment center on B, so it will just become 0, but the y component of it here and the x component here, so as you can see, the x component will go directly to the moment center, but our resultant, the component x of the resultant, component y of the resultant will have this distance of 40. So we will include that to our equation. So 8,000 sine 60 times 40. So so I forgot to put so we will still equate that to 0, because we are still in equilibrium force. So we are now in here 3 coplanar forces in equilibrium are concurrent. So still in equilibrium, so we will still equate that to 0. So we can transpose this, so we will have RA times 60 equals to 8,000 sine 60 times 40, then divide both sides by 60. So this will be cancelled, or it will become 1, and the remaining will be RA, and RA is just equal to 4618.8. 4618.8. So it is pounds. So this is our RA. So now we already have the RA, and to find RBY, so I would just like to sum up forces y. So because we already have the RA, we can earlier we cannot just sum up forces y because we have two unknowns, right? But now we can use summation of forces y to solve for RBY. So summation of forces y equals to 0. So always we will equate that to 0. So using our RA, 4618 going up, so 4618.80, so minus our x component, y component of our, so we would like to put this here, sine 60, so that is our y component of the resultant. So minus 8,000 sine 60, then RBY, and it is going up, so it is positive, equals to 0. So transposing that, we can solve for RBY. So our RBY is just 8,000 sine 60 plus RBY. So we have 2309.40 pounds of RBY. So we will also find the RBX. So RBX is just equal to summation of forces x equals to 0. So now we will be using the x component of the resultant because it is just the summation of forces x. So we have now 8,000 cosine of 60 positive minus RBX equals to 0. So RBX is just equal to 8,000 cosine of 60. So we have 4,000 pounds RBX. But we are not done yet. This RBX and RBY is just the component of the the resultant of B or the RB. So what we are solving is not really the RBY and RBX, but we are solving this and the RA. So we are solving this RA and RB, but we needed the RBY and RBX to solve for RB. So to solve for RB, so we know that so this is just the resultant of these two components, right? So RB is just the resultant of these two components. So we know that resultant is just equal to summation of forces x and summation of forces y. But in this case, we will be using RBX squared plus RBY squared. So using these two, we can solve for the RB. So put this RB. So our RB is just equal to 4,000 squared plus 2309.40 squared. So 4618.80. So this is our final reaction at point B. So these two is the what the book asks us to solve, but we don't know the angle yet of B to the horizontal. So to solve that, just like the to solve for, if you notice from my previous videos, so I am solving for the angle of the resultant, and what I am using is the tangent of theta. So forces x and forces y, but in this case we will be using RBY and RBX. So RBY over RBX. So our tangent is, our theta is just equal to inverse. So RBY is 2309.40 over 4,000. So our theta is just 9.40 plus 4,000. So as you can see, it's 29.99 or 30 degrees. So if we compare it with the book, so 4618 and 30 degrees to the horizontal. So the book also has 4620 and 30 degrees with the horizontal. So we just have 1.20 difference. So it is acceptable answer. So the book has 4620, we have 4618 both. So the angle is correct. So these two still or these three are still correct. So that is how you solve for this problem. So for our next tutorial, maybe I would like to solve for okay I would like to solve for these one, two, three problems. So I don't know if I will be solving that at the same time or in different video tutorial. So just if you want to be notified, so please do subscribe so you will be notified when I will upload the video tutorial of these three problems. So I hope you learned something. So this is my solution. So I hope you learned something, guys, today. So thank you for watching, and if you notice some error and mistake in my solution and in my explanation, so please don't hesitate to comment down below. So that's it. Thanks for watching, and please do subscribe. Thank you.